This will add to yesterday's notes about our composition functions, but there were several homework problems that asked you to also find the domain, so you'll have to do that on some of those. So here's how we find domain by hand. So you don't always have to look at a graph. You only have two issues that we're going to talk about when we have a domain, and that is having x in the denominator because we cannot divide by 0. So we set whatever's in our denominator equal to 0 and solve for x. So your domain is all real numbers except for what x equals with our denominator. If x is under the square root, we cannot have any negatives because that makes what kind of answers? Not real, imaginary answers. And so we set what's under our square root greater than or equal to 0 and then solve for x. So our domain would be x is greater than or equal to that number. So let's look at these three examples down here. The first one has a fraction, so we have x in the denominator. So we set the denominator equal to 0 and solve for x. So x minus 2 equals 0. So x would equal 2, just like what we did in our last unit. So our domain for this problem is all real numbers, and we change that equal to a not equal. So when you see a fraction, take whatever's in your denominator, set it equal to 0, and solve for x, just like we did in our last unit. Now, you had a few problems last night where maybe you could factor and cancel some things out. Remember, if it cancels out, it still needs to be part of that domain, just like our restrictions. All right, question 2, very similar. So take what's in your denominator, set it equal to 0, and solve. What would you do to solve that one? Subtract 2 and then square root. Now, what happens when we square root? It's imaginary. Do we talk about imaginary numbers when we talk about domain? No. So your domain for this one is just all real numbers. Yeah, or no restrictions with it. Yep. Now, question 3 is not a fraction, but it is a square root. So what does it say to do up there? Set what's under the square root greater than or equal to 0. And then what would you do to solve? Subtract 2. So x is greater than or equal to negative 2. So your domain is all real numbers that are greater than or equal to negative 2. Now, if you had, and I know some of you had this last night if you started on that homework, but let's say that we were just adding like equations together and end up with an equation like this. Does this have a denominator? Does it have a square root? So are there any issues with our domain? No, our domain would be all real numbers. So you only really have issues for our class when you see a x in a denominator or x under a square root. Does that make sense? All right. Now we're going to move on to our notes for today. Your notes for today, I actually have them printed for you. So here you go. Take one and pass it around there while I pull it up. Today's all about inverses. So we'll go over some inverse problems. How many more we got? There's one. Oh, look, write them out. All right, so make this go a little bit more horizontally, and we're going to start at the top left, and it goes side to side, top to bottom. Okay, left to right, top to bottom. So today is all about inverse functions. Now think about the word inverse. What is the inverse of something? It's the opposite. Exactly right. So when you hear inverse functions, think about the opposite. The inverse function undoes the original function. All the operations switch, which is bullet number 3. So addition would go to subtraction. Multiplication would go to division. Other things that happen is your x and y values switch. Okay? If your x and y values switch, then that means your domain and your range also switch, because domain deals with x and range deals with y. So if you switch the x's and y's, the domain and range will also switch. If you want to look at it graphically, the graphs reflect across the line y equals x. Now, if you remember some things from Math 2, think about that transformations unit that we did. Remember when we plotted like our triangles and then we reflected them over and we had all the rules? Well, the rules for reflecting over the line y equals x was x equals y. They just switch. So if you have a coordinate point xy, the new coordinate point was yx. And so that's what happens with inverse functions. All the x's and y's switch, so all their operations switch, their domain and range switch. So here we have two functions. This blue function is our regular old parabola, and we want to find the domain and range of that function. So what's the domain of a regular old parabola that opens up like that? Well, it is. The equation would be y equals x squared, right? So what's the domain of it? Domain is how far the graph goes left and right. Draw a quadratic in the air. How far does it go left and right? An infinite amount. So what do we say for domain? We don't say infinity, but we say all real numbers. Now, your range is how far the graph goes up and down. Looking at this blue parabola, does it go everywhere up and down? No, it goes up. So we would say y is greater than or equal to, where does it look like it starts at? 0. Now we answer this question, is it a function? This is a yes or no question. To determine the answer to that, we use our vertical line test. The vertical line test says if a vertical line crosses a graph only once, then the graph is a function. So for this parabola, it would be yes. You're exactly right. Because if we took a vertical line and laid it on that parabola, it would only hit that parabola once. Because even though it looks like it goes straight up kind of at the edges, it actually goes out a little bit as it goes up, right? If you were plotting those points, it would go up and out. So it does pass the vertical line test. Now, with any parabola, once we find the inverse of it, the inverse gets reflected onto its side. So this red graph is the inverse. And when you see this little -1 power right here, it means inverse. So now what we want to do is find the domain and range of the inverse of that parabola, which is the red one laying on its side. So domain again is how far the graph goes left and right. Does this red graph go everywhere left and right? No, it only goes to the right. So we would say x is greater than or equal to, and where does it look like it starts at? 0. Now, range is how far the graph goes up and down. Well, this parabola now is on its side, and it gets wider as it goes out. So how far does it go up and down? All real numbers. If you look at this fact, it will help you. Remember, the domain and range switch. So the domain of the function is the same as the range of the inverse. And also, the range of the function is the same as the domain. Notice how they're both greater than or equal to 0, but range is all about y values and domain is all about x values. You are correct. So our next question says, is this a function? If I put in a vertical line here, it hits here and hits here. So is it a function? No. Because that vertical line hits through that graph more than once. All right, so what we're going to do next is we're going to look at 4 different types of functions, and we're going to answer these questions based on the types of graphs and things that we have. So go to the top right part of your notes, and we're going to look at a table. Now, a table of values is basically how many coordinate points you have. So how many points do we have here? 4. We got 4 points. So if you were to graph this, you don't have to. But if you wanted to graph it, you have a point here, a point here, a point here, and a point here. If you wanted to do a little sketch, it's just those 4 dots. So the first question says, what is your domain? Well, what does domain refer to? X's, right? How many x values do we have? 4 of them. We list them out in curly brackets from least to greatest, but don't put the repeated one. So your domain in curly brackets is just -1, 0, 1. So make yourself a little note. List, least to greatest. No repeats. So even though 1 repeated, we don't put it again. And try to make those curly brackets. It doesn't have to be perfect, but just try. Now, range is similar, but instead of x, we use y. So what is my range? 1, 2, 3, 4. Now we have our question. Is it a function? Well, imagine if you plotted these points like I've done here. Is this a function? Does it pass the vertical line test? No, it doesn't. And why not? What 2 points does it go through? Oh, good, you said it. At 1. The 1's repeat. So is it a function? No. And if you need to, make yourself an extra little note here. X repeats, because it's going to go through those values of 1 twice. So if all the x's are different, you could say yes. But if the x's are the same, you say no. All right, to find the inverse of this, will you just make a new table? Because all you have is these 4 points. Now, look back on the left side. What's the first bullet say there? X's and Y's switch. So now what are my new x values for my inverse? 1, 2, 3, 4. And what are my y values? Very good. And that's all you have to do for a table. You just switch those x and y values, and there you have them. So now to answer this next question, what is the domain? So these questions are all about the inverse, these last three questions. So now what is the domain of my new table? 1, 2, 3, 4. And what is the range of my new table? So list out the x values from least to greatest, no repeats. Y values, least to greatest, no repeats. Is the inverse a function? Yes. Why is it yes? The x's don't repeat. All the x's are different. Any questions? Now, all tables are different, so you may have different values, but this is how you do tables that you have. You only have one of these on your homework, so make sure you go back and look at your notes to make sure you know how to answer these questions. Okay? Does that make sense? We sure do. All right, so let's look at our next function. So bottom left, what type of function is this if you wanted to graph it? It slopes, so it's a linear function. Linear functions have a lot of things in common. Now, as long as that linear function slants a little bit, a lot of things are the same. If it's a straight vertical line or horizontal line, it messes some things up. But this is a linear function, looks like a line, has a little slant to it because it has a little slope. No matter what, think about a line in general. What is the domain of this line? All real numbers, right? It's going to go on forever, left and right. What would be the range of this line? Nope. All real numbers. Even though it starts at a y-intercept of 2, it's still graphed both ways, right? So your range would be all real numbers as well. Is it a function? So when you have a graph, does it pass the vertical line test? Yes, it does. Now, before we move on to part D, we can actually answer parts E, F, and G. If we have a linear function, think about the last bullet there in the top left. It says graphs reflect across the line y equals x. Well, if you take a line and you reflect a line, it's still a line. What is the domain and range of that line? All real numbers. Is it a function? Yes. These 6 things that we have answered right here are true for any linear function. So if it is linear, all real numbers for domain and range. Is it a function? Yes. Those 6 things are always the same. You have 2 of these on your homework, so you have these 6 questions already answered automatically. Okay, so let's talk about inverse. Now, to find the inverse, you have to switch x and y, then solve for y. So switch the x and the y, then solve for y. So in this equation up here, I'm going to switch where those are, and it would be x equals 3/4 y plus 2. Now, get y by itself. What would you do to get y by itself? Not yet. You would subtract the 2 first. So get the thing furthest away from y to begin with. So since it was to add 2 on one side, it's going to be a minus 2 on the left side. Then you could multiply by what? Divide by that would work. Yeah, you could divide by that fraction, right? Because that is multiplying y. I'm going to give you another way of doing it because dividing by a fraction could split it up some. And if you take x, You take x and divide it by 3/4. Are you going to leave your problem like that? That looks a little tricky, right? So here's a way to help split it up to make it easier to solve. Get rid of the 4 first. The 4 is dividing on this side, so we would multiply by 4. Now make sure you multiply everything by 4. So you end up with 4x minus 8 equals 3y. Now you can get rid of the 3 by doing what? Dividing. And once you divide one thing by 3, you divide everything. So this becomes 4/3 x minus 8/3 equals y. And now y is by itself. And if you were to graph that function, it would be a line. It'd be linear. Yep. Do what? Yeah, you can change the order too if you want to. Still, you can say y equals 4/3 x minus 8/3. Your goal is just to get y by itself, so it doesn't matter what order you put them in. Does that make sense on how to solve for y? All right, let's do our next problem. This one is what type of problem? Quadratic. That's right. It's got a squared in it. It is a quadratic. And what shape do quadratics make? Parabolas. And they could either open up or they could open down. Now, does anybody know what form this quadratic is in? Some of you did it on your project, but you didn't have to. It is in vertex form. So you could actually state out what your vertex is from this problem. But if you're not sure, you can always look at your graph. So go to y equals, mine has frozen, and type in this equation. So everybody grab those calculators out. Go to y equals, type in this equation. And let's look at a picture of it. Now, you might want to hit zoom 6 to make sure we're all looking at the same picture, but it really doesn't matter as long as you see that parabola shape there. So this is one that opens up, right? Now, we could find the domain of this parabola pretty easily. What would be the domain of this parabola? All real numbers, because it's going to open up and get wider and wider. Is the range all real numbers for a parabola? No. What do we need to find in order to help us find the range? The y part, not the y-intercept, but it's the y part of the vertex will help us because that's the lowest point on the graph, so that will help us find our range. So if we find this lowest point, that will help us. So let's go to second trace and choose option 3 for minimum. Now, your calculator asks you some questions, right? When we find minimum, it says left bound, so go to the left and hit enter. Then it says right bound, so go to the right and hit enter. And enter on guess. It may give you some weird decimals, but if you round to just 2 decimal places or just round your numbers, the vertex is at -1, -1. So make a quick sketch of this, maybe to the side. Draw your XY axis. Go to -1, -1. Put a dot. That's your vertex. And then make that parabola shape. A lot of the parabolas that we will do today, you'll type in your calculator and find out what that vertex is, because that's going to help you answer the questions. We already talked about domain of this would be all real numbers, but our range would not be. It would be y is greater than or equal to -1. We use that y value from our vertex to go there. It's greater than or equal to because the graph opens up. What if your graph opened down? It would be less than or equal to. Very good. Is it a function? Yes, it is. It passes the vertical line test. Before we answer part D, we can answer parts E, F, and G. The domain for the inverse is the same as the range, but instead of y, we use x. So our domain for the inverse would be x is greater than or equal to -1. And what would our range be? All real numbers. So remember, these two are just opposites of each other. Whatever you put for domain would be the range over here, and then whatever you put for range or function is domain of the inverse. Now, think back to that first problem that we did at that top left. Is it a function for the inverse? No, because it's going to be laid on its side, so the inverse is not a function. So if you're trying to look at ones that are always the same, didn't mean to highlight so much, it would be parts F and G and A and C. No matter what quadratic you have, those four answers will always be the same. The domain is all real numbers, which means the range of the inverse is all real numbers. The function, or the original is a function, the inverse is not a function. All right, let's actually find the inverse. We do it the same way we did the last problem. So switch x and y and solve for y. Now remember, f of x is a fancy way of saying y equals. So we say x equals y plus 1 squared minus 1. So replace the x and y, but now you have to solve for y. Start with the furthest thing away from y and get rid of it first. So we're going to plus 1. X plus 1 equals y plus 1 squared. Then what would you do? Square root. You're exactly right. We're going to square root both sides. Now, on our left side, anytime you take a square root, don't forget to put plus or minus at the beginning. And on the right side, it's just going to cancel out the squared, and the parentheses can go ahead and go away. Now, what would you do to get y by itself? Subtract the 1. Can I subtract the 1 to this plus 1 under the square root? Nope. I'm going to put that minus 1 in the front. You can put it before your plus or minus, and that makes it a little bit easier. And again, if you want to change the order, you can. You can say y equals -1 plus or minus square root x plus 1. But do whatever steps you need to do to get y by itself. All right, turn the page. Now we're going to look at this function. This one is called a square root function. Does anybody remember what a square root function looks like? Well, let's graph it on our calculator. So grab those calculators. Do what? It does look a little different. Usually my calculator stops working in third period, but today it's second period. So square root 3x minus 4. And then don't forget to right arrow and put plus 2, because that plus 2 is not under the square root. Now, if you hit graph, what does it look like? It's actually half of a parabola. That's what happens with square root functions. It's half of a parabola, but laying on its side. Now, square root functions either go up and over, but they always go to the right, or they could go under and to the right. So a basic square root function looks like one of those. We did graph these a lot in math too, but it's been a long time. Now, we are going to find our domain and range. Look back at the notes you did at the beginning of class today. We did them on notebook paper. What does it say about domain if you have a square root? Good. You take what's under the square root and put it greater than or equal to 0. That's how we find our domain, and it's easiest to find it by hand. So take whatever's under the square root, put it greater than or equal to 0. Now solve for x. So we would add 4, then divide by 3. So your domain is x is greater than or equal to 4/3. I want to show you another little trick. If you go to your calculator and hit trace and type in x being 4/3, where is that on your graph? It's like our starting point, right? It's where that graph starts at. That's right. Yeah. I don't know if you're seeing it like that, though. But yeah, 4/3 is where you start at, which is our starting point of this graph. And then what's our y value? 2. Where do you see 2 at in our equation? Right here. So if we wanted to actually graph this one, it would start at 4/3 and 2. So you get the 4/3 by what's underneath the square root, and the 2 is coming from what's added on. It's like our translation. Our graph goes right 4/3 and up 2. Remember doing translations a long time ago? That's how it works for this one. So your range would be y is greater than or equal to 2. So you use your starting point from this square root function, and that's how you get those x and y values. So x value coming underneath the square root, the y value coming at the end. Make sure you graph it, though, just in case it opens downward instead of upwards. Now, once we have those two answered, we can answer part E and F, because E would be the same as, so we would say x is greater than or equal to 2. And what would you say for range? Greater than or equal to 4/3. Yep. Don't forget to change it from an x to a y. Now, are they functions? So first, is the original a function? Does it pass the vertical line test? Yes, it does. What happens with this half of a parabola when you do the inverse of it? Instead of being on its side, it's now going to open upwards. So it's half of a parabola, or normal parabola. So is it a function? Yes. The only two things that are always true with square roots are these two yeses. So if you have a square root problem, you can answer those two will always be yes. The function and its inverse always exist. All right, now to find the actual inverse, we switch x and y and solve for y. I did not make that a y, did I? What would you do first to get y by itself? -2. Then you're going to square both sides. Now, when you square this left side, leave it in parentheses. You do not have to write it twice or FOIL it out or anything like that. You can leave it as a parenthesis as the whole quantity squared. Okay? Then what would I do? Add 4. Can I add 4 to the 2? No. I just have to tack it on to the end because that's in a parenthesis. That's the whole quantity by itself. Divide it all by 3. Now think about what we did when we divided by 3 on that linear problem. We divided the x term by 3, the constant term, and then the y. You do the same thing here. But what happens when you divide something by 3? You could write that a different way. Like x divided by 3 could be written as 1/3 x. So that's how we're going to write this one. 1/3 x minus 2 squared plus 4/3 equals y. Now, if you actually graphed this, it would actually make a whole parabola shape. But remember, this should just be half of it because of the domain just being half of that problem. All right, any questions so far? All right, we got a few more things to go through. I know this is kind of long today, but it all kind of relates to each other. All right, so next problem says we're given y equals x plus 5. Find f to the negative 1 power. What's it asking us to find? Inverse. Good. So in case you forgot, write the word inverse there. Now, how do you find the inverse of this? Switch x and y. So x equals y plus 5. And then we would need to subtract the 5 to get y by itself. Now what you might want to do is write these as two different functions. F of x is our original, and f to the negative 1 power is the inverse. So the original function is x plus 5. The inverse is x minus 5. Does that make sense? The inverse is the opposite operations, right? So if the function is plus, the inverse is going to be minus. Now, this is a good review of yesterday. Those of you who watched yesterday's video, took notes, you know what to do here. So what do you do when you see f of f inverse of 3? That's right. You find this first. Work your way on the inside and then go to out. So we find the inverse of 3. So that means we take 3 and plug it into the inverse equation. So what's 3 minus 5? Negative 2. Now that we found that answer, we just kind of substitute it back in there. So now it's f of negative 2. Now plug that back into the function f. So negative 2 plus 5 is 3. So we find the inside. Once you find that answer, plug it into the other. But what do you think happens here when we do the function and then the inverse of the function? Well, inverse means what? Opposite. So we do something and then we do the opposite of something. So what's going to happen? It's just going to cancel out, right? If you do it and then do the opposite. What if you do the opposite and then do the original? What's going to happen here? It's just going to cancel out too. So what are we going to be left with? 3. Oops. Meant to move the whole thing. So what do you think is going to happen with these two problems? Once we find the inverse and then we do the original function. That should be a negative right there. So what's f of f inverse of 100? 100. What's f inverse of f of negative 50? Negative 50. So if you plug something in the function and then plug it in the inverse, it's just going to cancel out and give you back what you started with. All right, here's the other thing that we're going to do today, which is a little bit review of yesterday, our composition functions. So this is a key fact that you need to know, so make sure that you put a star by it, okay? If f of g of x equals x and g of f of x equals x, then the functions are inverses of each other. So if you can find those two things and they both equal x, then you can say that they're inverses. So let's have these two equations and let's find those things. So f of g of x. Now, we know what g of x equals. What is g of x? So I'm really going to find f of 1/3 x. So that means I'm going to take 1/3 x and I'm going to plug it into where x is in the f equation. So f of x says 3 times x, but in the place of x, I'm going to put 1/3 x. So I take one equation and substitute it in the other. What is 3 times 1/3? 1. Yep. So this becomes 1x or just x. So does f of g of x equal x? Yes. Now we check g of f of x. So we're doing g of, well, what is the f of x function? 3x. And we're going to plug that into function g, which says 1/3 times x. Well, in the place of x, we put 3x. So what's 1/3 times 3x? X. So are they inverses of each other? Yes, they are. As long as both of those just equal x, we're good to go. All right, let's look at our second problem here. Now we're given j and k, but we still set it up the same way. Do j of k of x. So plug one function into the other. So this would be j of 1/3 x plus 1. So in the place of x, we put 1/3 x plus 1. So it's 3. And then 1/3 x plus 1 minus 1. So taking this whole function and putting it where that x is. Now, what would we do to simplify that? Distribute the 3. So what's 3 times 1/3? 1. 3 times 1. And then we bring over that minus 1. So it would simplify to x plus 2. Are those inverses of each other? No, because what should that equal? Just x by itself. So since it doesn't, you can just stop there and say no, that doesn't work. All right, the next thing we have on our list is saying which of the following functions have an inverse function. So which of those has an inverse that exists that is a function? Well, to answer this question, we're going to use something called the horizontal line test. The horizontal line test says if a horizontal line crosses a graph only once, then the inverse of that graph is a function. So it's similar to our vertical line test. The vertical line test says, is that graph a function or not? The horizontal line test says, is the inverse a function or not? So would this one pass the horizontal line test? No. So the inverse is not a function. What about this one? Yes. It looks like it gets real close in the middle, but it actually doesn't. What about this one? This one? This one? Yes on this one. What about this one? So any vertical line, no matter where it is, 4 of those would be yes, 4 of those would be no, because it doesn't pass that horizontal line test. So a horizontal line test will tell if the inverse is a function. It's kind of like doing the vertical. Yeah. All right, last set of problems we got. So flip to that last page. What is the possible domain of the inverse of that function? Well, remember, domain of the inverse is the same thing as the domain of the inverse is the same thing as the range of the original. So if we can find the range of the original function, we can find the domain of the inverse because they're the same. So what kind of function is that? It's a quadratic, right? So it's going to make a U shape. What's the domain of all quadratics? All real numbers. What about the range of this quadratic? Oh, Peyton's already grabbed his calculator. We're going to have to type it in to help us find our range, right? Because we need to find the vertex in order for us to figure out the range. So let's go to our calculator and type this one in. So we have 3x squared plus or minus 18x plus 5. So if we hit graph on this one, do you see your vertex? No. What are we going to have to do? Adjust the window. What part of the window are we going to adjust? The y minimum. We need to make it negative what? Maybe try negative 20? 20 doesn't work. So yeah, let's make it a negative 30. Good job. You were right. So change that y minimum to negative 30. Now do we see the vertex? Yes. Let's find it. How do we find it? Second trace minimum and go left bound and right bound. So the vertex is 3, negative 22. So what is the range for this function? Perfect. So what is the domain for the inverse? X is greater than or equal to negative 22. So remember, we use that range of the original to find the domain of the inverse. All right, last question. Does an inverse exist for the entire domain of this function? Well, what is this function? It's a parabola, right? So does the inverse exist? No, because it doesn't pass the horizontal line test. So the inverse does not exist. So you would say no. But we could limit the domain so an inverse would exist. Now let's talk about how we could do that. So we said that an inverse doesn't exist because it doesn't pass our horizontal line test. Because if a parabola opens up, a horizontal line would hit it twice. Now the inverse of a parabola is a parabola on its side, right? And so on its side, it doesn't pass the vertical line test. But if I could get rid of some of the parabola, would it pass the vertical line test? If I got rid of how much? Half of it. So if I got rid of half of the parabola, it would exist. Now, it doesn't matter what half you get rid of. It could be the left side or the right side. So let's figure out what domain we would limit this to in order for it to exist. So we need to find the vertex. The vertex will help us find what that domain would need to be. So type it in your y equals, find your vertex. You might want to hit zoom 6. So you got it typed in y equals, second trace, find your minimum. What's the coordinates of that vertex? Okay, great. Now, with domain, what values do we talk about, x or y? X. And we said if we got rid of half of our parabola, then the inverse would exist. So our domain, if we limit it to just half of the x values, then our domain would exist. So the half that we want to use, you can either use greater than or less than here. It doesn't matter. I'm going to do the right side, so as long as my x values are more than 3.5, I wouldn't have any repeated numbers that would make my domain work. All right, homework over the break. So you have your homework from yesterday, but then I'm also going to give you this worksheet, okay, that goes along with the packet that we just did. Now, I know it seems like a lot, but we've actually covered everything that you need to know for this unit. So when we get back from Thanksgiving break, on Monday, we're just going to spend that day reviewing the whole class period. And then on Tuesday, we'll take our test. And, oh, I don't know why I gave you 2. I'm sorry. You just need 1, don't you? All right. So don't forget on last night's homework, though, there were several problems that said go back and write the domain for. So you've got last night's homework and you got this worksheet to do. And you guys have about 35, 40 minutes to work right now. So the more you get done now, the less you have to do kind of over the break. Now, I suggest take a couple of days off, whether that's Thursday, Friday, or Wednesday, Thursday, whatever. But then work maybe 20 minutes just the other 3 days to finish up homework and review a little bit.